Okay, Year 10, I'm just going to go through some of these trig identities so that if you're having trouble with them, you might be able to work your way through them. Before I start doing these trig identities, I'm going to write a few things up here that I need to know to be able to solve them. So the first one I need to know is that tan theta equals sine theta on cos theta. That's going to become useful. That sine of theta equals cos 90 minus theta. That's going to be useful. And the main one, sine squared theta plus cos squared theta equals 1. Now, I also need to know what happens if I get other versions of this. So if I divide by sine squared theta, what do I get? Well, I get 1 plus cot squared theta equals 1 on sine squared. Well, that's going to be cosec squared. That's going to be useful as well, cosec squared theta. And if I go the other way and I divide by cos theta, what do I get? Well, I get tan squared theta plus 1 equals sec squared theta. And I'll be able to get versions of those. Remember that if we want sine squared or cos squared, we can take it from this and go sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. Now, all these things are going to be things that we have to use to help us solve these different equations. So I'm going to pick up from question 5 because we didn't quite finish it. And what I wanted to do was 5e. And what have I got here with 5e? I've got cos squared 10 degrees plus cos squared 80 degrees. Well, cos squared 10 degrees, well, I'm going to use this rule up here, sine theta equals cos of its complement. I'm just going to write that as sine squared 80 degrees plus cos squared 80 degrees, and that equals 1. See how I rewrote cos squared 10 as sine squared 80? Because cos of an angle is sine of its complement. Okay, what else have we got there? Let's have a look at F, if you're having trouble with 5F. I've got cosec squared 20 degrees minus cot squared 20 degrees. Okay, well, what I have to do is I have to use one of those ones up there. So I can use the 1 plus cot. I might do that. So I'm going to use this one. And I'm going to go, well, cosec is 1 plus cot squared 20 degrees minus cot squared 20 degrees. And these two things will cancel out, plus 1 minus 1, and they'll just leave me with 1. So that one's pretty easy as well. Now, let's have a look at 6. So we'll take 6. We'll start with an easy one. 1 minus sine squared, or 1 minus sine squared theta. Well, we've already written that. 1 minus sine squared is cos squared. So cos squared theta is 6a. Let's have a look at another one. I'm not going to do all of them, but you can have a go at them. Let's just go across. Let's do E. Oh, well, I'll jump. Oh, no, because that's the same. Let's take D. And what have I got? 2 minus 2 cos squared theta. Well, let's factorise out the 2, and I get 1 minus cos squared theta. And 1 minus cos squared theta from above is sine squared theta. So 2 sine squared theta. And there's D. Let's try F, which is similar. And we've got 3 plus 3 tan squared theta. We'll take the 3 out, which will leave us with 1 plus tan squared theta. And we know that tan squared theta plus 1 is sec squared theta, so that's going to be 3 sec squared theta. And there's your F. Let's go along. What else have we got here? Let's go the I, the tan theta cos theta. So I'll go I, tan theta cos theta. Well, they're multiplied, but I know tan theta is sine theta on cos theta, and I'm multiplying by cos theta. And look at that, the cos thetas just cancel, leaving me with sine theta. Now what you can do at this point, if you're having trouble, you can just check on your calculator and put some angles in and see if tan 30 cos 30 equals sine 30. I did that on my calculator, but it's going to take me a while to get it up. I should have been a bit more organised. So what else have we got here? There's an I, there's a number 6 squared. What I'm trying to look at ones that might look a little bit hard. Let's have a go. Well, J is a difference of 2 squares. Let's have a go at N. Cos squared theta minus sine squared theta cos squared theta. Okay. So I'll do N and O. See how you go with that. So here I go with N. And N is cos squared theta minus sine squared theta cos squared theta. So cos squared theta minus sine squared theta cos squared theta. And if I factorise out cos squared theta, I'm left with 1 minus sine squared theta. And we know from previous that sine squared theta, 1 minus sine squared theta is cos squared theta. So a squared times a squared, well, that'll give me a 4. So cos to the 4 theta. Let's just check that N. Cos to the 4 theta. And the last one, O. Tan theta square root of 1 minus sine theta. Tan theta times square root 1 minus sine squared theta. Is that it? Righto. Well, the tan theta I can write as sine theta on cos theta. And the 1 minus sine squared theta I can write as cos squared theta. Well, that's okay. Sine theta on cos theta. Well, the square root of anything squared is just itself, so that's times cos theta. And now the coses cancel, leaving me with just sine theta. Now, the more you do of these, the better you will get. Now, I haven't done them all. I do want to now have a look at question 8. And you can skip 7 if you want. I'm not too fussed about 7. But 8, these are a proof. These are a proof. And you have to be very particular about how you do these. So I'll do every second one. So I'll do A, C, E, G. All right, and then you try the others. So 8A. 8A. And what have we got to prove? 1 minus 2 sine squared theta. 1 minus 2 sine squared theta equals 2 cos squared theta minus 1. 2 cos squared theta minus 1. All right, so here you have to get the left-hand side to look like the right-hand side, or the right-hand side to look like the left-hand side, or work them both down. But you shouldn't take things across the equal sign. So what am I going to do? Well, I'm just going to work the left-hand side. And this is how you set it out. So I'm going to take this left-hand side here. And I say the left-hand side. I'm going to try and get it to look like the right-hand side. So I've got 1 minus 2 sine squared theta. What am I going to do with that 2 sine squared theta? I need to get it as a cos theta. So it's 1 minus 2. And remember, I can write sine squared theta as 1 minus cos squared theta. Okay, so now we've got 1 minus, and now I've got to multiply it. Minus 2 times 1 becomes minus 2. And I've got minus 2 times minus cos squared theta. Well, that'll become plus 2 cos squared theta, which gives me minus 1 plus 2 cos squared theta equals 2 cos squared theta minus 1, because it doesn't matter which way I add them. And that equals the right-hand side, because look, they're exactly the same. And then I write this quod est demonstratum, as I've shown. And there you go. Now, I could have taken the right-hand side and made it look like the left-hand side, but I just grabbed the left-hand side. Possibly would have been easier to grab the right-hand side and work it down. Let's have a look at 8C. What do we got? 3 cos squared theta minus 1. Okay, so let's go over here. 8C. 3 cos squared theta minus 1 equals 2 minus 3 sine squared theta equals 2 minus 3 sine squared theta. Okay, well this time I'm going to take the right-hand side. So I'm going to take this side down and work it until I get it to look exactly like the left-hand side. So I write right-hand side equals 2 minus 3 sine squared theta. And I'm going to do the same again. This time I'm just going to go, all right, 2 minus 3, 1 minus sine squared theta. And you can see it's already similar. I'm going to do this expansion. That's going to give me minus 3. And this one's going to give me plus 3 sine squared theta, which is going to give me minus 1 plus sine squared theta. And I'll just rearrange that so that it's sine squared theta minus 1, which equals the left-hand side and QED. All right, let's have a go at 8E. What do we got? Sine squared plus tan squared equals sec squared minus cos squared. So here's 8E. Sine squared theta plus tan squared theta equals sec squared theta minus cos squared theta. Sec squared theta minus cos squared theta. Now my usual advice is to say, take the more complicated side and make it look easier. Both these sides are the same, but I think I'm going to take the right-hand side and make it look like the left-hand side. So the first thing, sec squared. Well, sec squared is the reciprocal of cos. So it's 1 on cos squared theta. And I'm going to write this as 1 minus sine squared theta. Okay, so I'm going to leave this alone for a moment, 1 minus cos squared theta. And I don't know if this is going to work. Maybe, okay, we'll see how we go. Minus 1 plus sine squared theta. Okay, this is going to be a bit complicated, but it's okay. Now I'm going to get a common denominator. So I need a common denominator, and I've got 3 terms. So I've got 1 on cos squared theta minus, now I'm going to multiply this 1 top and bottom by cos squared theta. So it's going to be cos squared theta on cos squared theta plus sine squared theta times cos squared theta on cos squared theta. Okay, let's see how this works. So I've got 1 minus cos squared theta plus sine squared theta cos squared theta. I don't think this is going to work. All over cos squared theta. I think I've made this too complicated. I don't think I'm going to be able to. Let's see. So let's take 1 minus cos squared theta, and I'll get 1 plus sine squared theta over cos squared theta. I don't know where this is going. I don't think I'm going to get there. 1 minus cos squared theta. Do I want that? And if I take 1 minus cos squared, I don't think this is going to work. And this is what I mean. Sometimes you're going to have to go back and try it again. I think I went down the wrong path there, so I'm going to try something else. Let's see if I can do it another way. I still reckon I've got to work out that other side. I still reckon I've got to work down this other. Did I write the same right equation? Let's double check. Sine squared plus tan squared equals sec squared minus cos squared. Okay, so I think I've got it right. Sine squared plus tan squared equals 1. I know what I'm going to do. I'm going to take the left-hand side. No, I know what I'm going to do. Still going to take the right-hand side, but I'm going to go back. I should have been a bit smarter. Here we go. Here's what I'm going to do. I'm going to take this. I'm going to write sec squared as tan squared plus 1. That was silly. Why didn't I do that in the first place? So I'm going to take the right-hand side. And what did I say that sec squared was? 1 plus tan squared. Oh my gosh, they're so easy now. Minus, and I'm going to write cos squared as 1 minus sine squared. Oh, too easy. That gives me 1 plus tan squared theta minus 1, minus minus here. When I expand this, I get a minus minus. So I get plus sine squared theta. Oh my, how ridiculous is this? The ones will cancel. 1 minus 1, leaving me with tan squared theta plus sine squared theta And I'll just rewrite that so it's in the same order because it doesn't matter which way we add it. Sine squared theta plus tan squared theta, which is the left-hand side, QED. And that's what I mean. You're going to have to sit down and you have to go through these and make sure that you take your time and have a couple of goes, and sometimes you'll get it, sometimes you'll have to go back. All right, so ACE, what else have I got to do? ACEG. I might do G and H just to finish. And you should have, if you feel confident, go and have a go at these and then come back. So I've got 2 cos theta plus 3 sine theta all squared. So this is G. So 2, what was it, cos theta plus sine squared? 2 cos theta plus 3 sine theta all squared. 2 cos theta plus 3 sine theta all squared. What does it equal? Oh, plus 3 cos theta minus 2 sine theta all squared. Plus 3 cos theta minus 2 sine theta all squared. Minus 2 sine theta all squared equals 13. Well, as soon as I see this, I know that what I'm going to have to do is I'm going to have to work the left-hand side. Because I can't, it's going to be impossible, well, very difficult to try and make the 13 look like that. So I'm going to try and simplify the left-hand side. So I go left-hand side equals. Well, let's expand this. This is going to be difficult, but you have done this. I'm going to expand that. That's an equation. So it's like I need to remember this. A plus B all squared equals the first thing squared plus 2 times AB plus the second thing squared. And for the other one, I'm going to have to remember this. A minus B all squared equals the first thing squared minus 2 times each of them plus the last thing squared. So let's see what that happens when I expand that. So I'm going to expand this. So it's a first thing squared. So it's 2 cos theta times 2 cos theta, 4 cos squared theta, plus 2 times 2. I'm going to do this step by step because I reckon some of you are going to have forgotten this. 2 cos theta times 3 sine theta. Okay, so I'm going to need a lot of room here. Plus the last thing squared. Well, 3 squared is 9. So plus 9 and sine squared theta. Sine squared theta. Now, plus, I'm going to do the same thing here. But remember, I've got minus 2 times the middle. So here we go. So the first thing squared is 9 cos squared theta. So the 3 squared and the cos squared. Minus 2 times 3 cos theta. 2 times 2 sine theta. Plus the last thing squared, 4 sine squared theta. And that's it. I'm just going to shrink it so you can see it all. Now, here I don't have to tidy up. Please look at it and realise that this and this are the same. You've got a 2, a 2 and a 3 all multiplied, and a cos and a sine multiplied. And one of them's plus and one of them's minus. So they cancel out. So now I'll just tidy it up. And I'm going to put the 4 cos with the 4 sine. 4 cos squared theta plus 4 sine squared theta. And then I've got a 9 sine squared theta plus a 9 cos squared theta. Oh, now it looks really neat. I'll take the 4 out, and I've got cos squared theta plus sine squared theta. and then I take the 9 out, and I've got sine squared theta plus cos squared theta. Now, I know that both of these things equal 1. Sine squared theta plus cos squared theta equals 1. So what am I left with? 4 times 1 is 4, plus 9 times 1, which is 13, which equals the right-hand side, which is QED. All right. Whoa. Now, if you're getting through these and you're able to do them, you are very good. This is, as I say, as I stress, year 11 work. So I'm going to do the last one here. What have I got? 1 on cos squared plus 1. 1 on cos squared plus 1 equals 1 on cot squared equals 1 on cos squared. 1 on cos squared plus 1. Cot squared on. So F, G, H. So this is H. And what have I got? 1 on cot squared theta plus 1 equals 1 on cos squared theta. So what I'm going to do is I'm going to take the left-hand side. So the left-hand side. Well, I know 1 on cot. 1 on cot. Well, that's the reciprocal of tan, so that equals tan squared theta. So I get tan squared theta plus 1. And I know that tan squared theta plus 1 is sec squared theta. Do you remember that? It's way up here. Let's go back and double check. Tan squared theta plus 1 is sec squared theta. Can you see it there? Okay, so let's go back down here. And if we keep going, well, sec squared theta is a reciprocal of cos. So it equals 1 on cos squared theta, which equals the right-hand side, QED. That one was easy. And if you go, no, it's not, you're right, it isn't easy. This is very difficult work. But the more you do, the better you will get at it. And you need to have a go at some of those yourself. Good luck.